Welcome everybody to more on solving equations in one variable. So we're just talking about one variable. As you can see here in these problems, we have variable D here on the first problem with a variable term. So we are going to be calling variable terms, we'll identify them as VT. Any constants, those -4 and -8, that's the term. Constants are going to be with a letter C. And in this situation where we're going to have these, what we call the three-step equations, that means that we're going to have variable terms on both sides. So in order to solve these, we're going to need to do some inverse operations. So let's recall how do we solve linear equations? So how do we solve equations? The question is, how do we solve equations? So I want you to think briefly to yourself. Think about the three things that we do to solve equations. Okay, the first thing that we do is that we look to see if we can multiply anything, and that's the distributive property. When you're looking at the distributive property, you're asking yourself, can I multiply? This is multiplication. Is multiplication possible? If you can multiply, if you can distribute, then do that. And then second, you're going to look, and these problem set is going to have some good examples of this. Can I combine like terms? What this is when you're combining like terms, this is adding or subtracting. But it's only adding and subtracting things alike on the same side. That's really important to understand that they are on the same side. So I'm going to show you something where I want to encourage you to really understand this. Ready? Here it comes. This is really important. Combine like terms is not inverse operations. You don't make the addition line that goes across and adding things down. You're just combining them together in a single step. Okay, so it's not. Combine like terms is not inverse operations. Inverse operations is the last 2 or 3 steps that we do. So that's the last thing. Third and last is inverse operations. Okay, of these, when we go to inverse operations, we do the additive inverse first. You don't, because it makes it easier. Additive inverse first. You might have to do it twice if you have variables on both sides. Yeah, like we're going to do today, variables on both sides. You have to use this one. You have to do additive inverse, do twice. Okay, the very last thing gets you your 1x or 1g. That's the very last thing. The last thing is your multiplicative inverse. Sometimes you can divide if the coefficient is, so this is the reciprocal of the coefficient. You can divide if the coefficient is an integer, then you can divide. But most of the time, the coefficient in 8th grade is a fraction, so we want to take the reciprocal of only the coefficient. We're not dealing with the variable. Okay, so let's go along here and identify our variable terms, and you're going to do this on your paper. This is a variable term, a constant, a variable term, and a constant. So we have our vertical line. We know that we want to get rid of our, we have to do additive inverse first. Additive inverse. And in this case, we have to do it to the entire variable term because we need to get it onto one side. Let's see what happens if, let's pretend for a second if I subtracted 5D instead of subtracting 4D, which is of course easier. I slash out the 0, and I have 4D minus 5D is negative 1D. And then I bring down things I don't do anything to. This is 0, so it's just slashed. Here's my two-step equation. I need to do the additive inverse again. And this is the additive inverse of the constant. So I'm adding 4, slashing. Here we go. Bringing things down. Negative 1D.
Good morning, teachers. Can you please report to your morning yard duty? Report to your
Negative 8 plus 4 is negative 4. And then I am going to need to get not negative D, but positive D. So I'm going to, I can multiply by negative 1 both sides, or I can divide by negative 1. And that gets me my positive D equals positive 4. Let's go ahead and look at the next problem. Okay, so here on this last step we did, we divided by negative 1. Here we have a situation. Let's identify our variable terms and our constants. Take a look at what we have here. We have a constant and a constant. Constants are like terms. So we're going to combine them. So combine. And we're going to combine them in one step. So we don't do inverse operations. Let me put a little parentheses. Not inverse ops, exclamation point. This is not an inverse operations step. So we have variable term, constant, variable term. Here we're you can highlight if you want to have if you want to add things together. Let's review the rules for adding and subtracting here. Just a really quick review. Make sure you jot this down in your own personal notes. Here's a quick review of the rules for adding and subtracting negative numbers. They're pretty simple. Okay, here we go. If the signs are the same, you add the numbers. And you keep the sign. Super easy. So if I had a negative 4 minus 7, I add the numbers for 11, keep the sign. Okay, same sign. That's the same sign. So if they're both positive, it'd be positive. Okay, opposite signs are different signs. Super easy also. That is, you subtract the numbers and keep the sign of the larger number. So if I had a negative 7 plus 11, I'm going to subtract those. 7 minus 11 is 4, and see how this is larger? The larger number is 11, so that's positive 4. Let's imagine I had 7 minus 11. This time I'm subtracting the numbers, and the larger number is negative 11, so this answer is negative 4. So those are your rules. Feel free to screen capture it or write them down. So here we have -3 plus 5. Subtract the numbers. It would be 2. The larger number is positive, so this is +2 plus 6g equals 11 minus 3g. That exhausted our, we're following our order, or how to solve equations. So we did this. Once you've finished the first and second thing, you're done with those two. You're only on inverse operations at the end. So we have to get rid of the add for the variable term first. Let's keep it positive by adding 3g to both sides. And slash. You always align to the common term. So this is a variable term. So I want to go plus 3g to the variable term here. I bring down things I don't touch. 2 plus 9g equals 11. Now I'm at my 2-step. I'm trying to get g alone, right? So I'm going to subtract 2. There we go. We're getting closer. Bringing down the 9g. 11 minus 2 is 9. Finally, it's an integer. I can just divide by 9. And I get my 1g equals 1. Okay. So we have the same situation here. Notice that we have 2 constants on the left. We need to combine that in the first step. Now, these examples, you want to write your variable term first as a rule. We call that descending order. So I'm going to write the 4h. I have my variable term, my constant, my variable term. Now, remember, the variable term includes this negative, so that's going to be important here. 17 plus 2 is 19 equals, I got a little off on my vertical, 1 minus 5h. And now I'm working to get rid of these variable terms. Let's just subtract 4h just to practice our rule of addition and subtraction. Slashy, bringing down, making sure, oh, it's positive 19, that's great. I don't want to leave behind a negative. 1 minus 9h, okay. 2-step, subtract 1. 19 minus 1 is 18. And notice, negative 9h. I don't leave behind my negative sign. That's important. The negative sign is equally as important. Let's do a practice of multiplying by the reciprocal. We could divide by -9, but what is the reciprocal? The reciprocal here is 9 over 1. That's the coefficient. So here I'll just write coefficient is -9 over 1. Okay, so it doesn't include the h. It doesn't include the variable. It's very important. So what is my reciprocal that I'm going to multiply by? I'm going to flip over the coefficient, and it's going to be -1 over 9. So let me multiply by -1 over 9, -1 over 9. And we'll do a little practice here. We do that to get h on the right. Now, what do we end up here? People get a little confused. It's not cross multiplying. This is multiplying a fraction times an integer. Or if you want to take that integer and just put it over 1, now we have numerator to numerator and denominator to denominator. And all we have to do is simplify that. H equals -2. Now you might be saying, oh, a negative over a positive. Mr. Garrigus, what are those rules? Remember the multiplication of a negative. The rules are pretty simple. It's a positive times a positive. So let's just do +1 times +1 is +1. Positive, if they're different, then it's negative. -1 times +1 is negative. Only when they're the same, and that's +1, sorry. Also, what is the negative sign in a fraction? The negative sign in a fraction, let's say I had this negative, well, let's just use 9 over 1. Okay, so that negative sign could go into the, one of these is negative and positive. So that's why we have a thing. So you can move the negative into either the numerator or the denominator. So I could get negative 9 over 1, or I could make it 9 over negative 1, like that. So we got all that working for us. These rules, again, feel free to screen capture this and save it to your notes for all time if you want. You can write down the notes into a separate journal. And we're almost done. We're going to do one more, and then there's 4 problems on the back that you're going to be partnering up with in a group or working by yourself to solve. So those need to be finished at some point here. Let's do our vertical line here. I hope I don't run into that writing. Okay, I have constant, variable term, that's a T, and a constant. So I have 2 constants and 2 variable terms. What do? Of course, we know that we need to, we're going to be getting rid of one of the variable terms, but this one's in halves and this is in a whole number. So I need to convert -2 into equivalent fraction. And that equivalent fraction is -4 over 2. You might be asking, Mr. Garrigus, how did you get that? Oh, okay. Well, you want to go -2 times 2 over 2. See, this number is the equivalent of 1, but it's 2 over 2. So I get -2 times 2 is -4. And in the denominator remains the 2. So I haven't changed the number. I just took like 2 whole pizzas, cut them in half, and now I have 4 that I've given away, 4 half slices. But 4 half slices of pizza is still 2 pizzas. Okay, so let's rewrite this. 16 minus 4 halves t equals 3 halves t plus 9. Let's work with positive numbers by adding 4 halves t to both sides, so we don't have to work with any negatives. Slashy the 0. We didn't do anything with 16. Now remember, this is a positive 16. The sign for the number is out in front, but we don't run around writing positive 16 because we already know without a sign. It's by default. If we didn't write the positive sign, we know that's our default. 16 equals, and keep it in column. Keep the equal sign here. This is 7 over 2. When you add, and it's a t, there's a variable term. When you add fractions, you're adding the numerator, and the size has to be the same, so the size doesn't change. Bring down the plus 9, making sure that you're checking to make sure this sign is staying the same. We're almost done. Subtract 9 slash 7 equals 7 over 2t. What is the reciprocal of 7 over 2? Now we're looking at just the coefficient. So we're going to multiply by just the reciprocal of the coefficient, 2 over 7. No t. No t. Not. No comma t. Times 2 over 7. That was funny. The 7's cross cancel, but if you don't know how to cross cancel, you can do it as 14 over 7 equals t, and then reduce it to 2 equals t. Those of you that are a little bit more advanced here, you recognize that a 7 is in the numerator and a 7 in the denominator. Cross cancel. 7 goes into 7 once and 1, and you end up skipping this step and ending up with, and we'll go through and we'll circle all of our answers. If they were a little bit harder problems, we might go through and check our work. Okay. So again, you'll have a paper here, and you can see that Yours will say Unit 2, Lesson 2, Part A, solving equations in one variable with variable terms on both sides, 3-step equations. These are going to be your notes. You're going to work in a group or by yourself on the second page here, and there may or may not be an assignment for you to take a picture of this work and turn it in. So you always want to keep these notes in a very organized way in your binder or a folder or something like that. Okay? All right.